Alright everybody, welcome to the next video. This video is going to be on dealing with percents and dealing with percents in algebra problems, which is a skill that you'll find useful throughout your life. This is basically how you can figure out how much tax is going to be on an item, or you can use this to figure out how much you're supposed to tip someone. Or, if you're given a percentage, you can figure out what that actual number is. If you're told 50% of something is a certain way, you can figure out how many things are that way then. So, let's dive right into seeing how these problems work. Before, though, we need a little bit of vocab. The first word is of. You will see of in these problems a lot. When you see of in a percent-based problem, what that means is multiplication. So we have multiplication for of. So of will basically mean times. Is will always mean the same thing as well. In fact, you've seen is before in equations, and it means the same thing. When you see is, that's going to mean equals. So we have our equals there. We have multiplication going on here in the of. Percent literally means out of 100. When we're given a percent in these types of problems, we're always going to want to make them become decimals. So that's something really important to remember. We're always going to want to turn them into decimals. Now, if you don't remember how to do that, let's say that we're starting with 30%. There are two approaches you could take. The first approach is you could take your 30% and divide by 100. Use your calculator for that. And once you have that, you figure out that that's 0.3. Second approach you could take is start with the 30%. The decimal place is after the 0 right now. To turn things into a decimal instead of this percent, you would move the decimal to the left twice, and that would give you also 0.3. So looking down here, looking at example 1, part A, we need to find the percent from that decimal. Well, to go from decimal to percent, you could either multiply by 100 or move the decimal place over 2. So, to the left, to the right, I mean. So 1, 2, we see that that becomes 8%. If we start with 53.6%, we move the decimal place twice to the left, and that gives us 0.536. On this one, if we start with 0.92%, we again move the decimal place 2 spaces to the left. Any extra spaces we create, we put a 0 for, so we end up with 0.0092. And starting with this decimal, 0.7645, since we're going from decimal to percent, we'll move to the right twice, putting us at 76.45%. There it is. So we need that decimal conversion happening because we don't want to use percents actually in these problems. Okay, so here's our first example. What percent of 225 is 77? Now in this case, we're looking for a percent as the final answer. We don't know what it is yet though, and when we don't know a value, we use x, or we use a variable, because we don't know what that value is at the moment. So we're going to stick with x for now. Remember, of means multiplying, and then we have this number 225. Is means equals, and then we have this number 77. So right now we have x times 225 equals 77. Well, we need to get x by itself, so we have 225 times x. To get rid of times 225, we'll divide both sides by that number. The 225s on the left cancel out, and you may want to use your calculator to figure out, of course, what 77 divided by 225 is. Might not be easy to do on your own. So I'll do that, and we get that x equals 0.342. Now this is a decimal. We want to percent. So remember, to go from decimals to percents, we're going to move the decimal place 2 to the right, which tells me that we have 34.2%, which means that 77 is 34.2% of 225. Next example, 298 is 72% of what number? 298 means equals 72%. Remember, in dealing with these problems, we're going to need to turn that into a decimal. So here's the current decimal place, 1 space, 2 spaces. We're going to have 0.72 there. Of means times, and what number means x, a variable. We don't know. So setting this up is 298 equals 0.72 times x. So we're going to get x by itself. We need to get rid of that times 0.72. So we just divide by 0.72 on both sides. The 0.72's cancel out on the right. 298 divided by 0.72. We get that x is about equal to 413.89. There we go. That one's done. Okay, example 4. What number is 7% of 1,234? What number means x? Is equals. 7% we need to turn into a decimal. 1, 2. We have a 0 there. So that's going to be 0.07. Of means times, and that's going to stay the same. So x equals 0.07 times 1,234. So we type that into the calculator, 0.07 times 1,234, and we get then that x equals 86.38, and that's 7% of 1,234. Next, find the percent for a tip, for a $12 tip on a $50 meal. Basically, what we're wondering then is $12 is what percent of $50? So $12 is what percent? So $12 equals what percent? We don't know yet, of $50. We need to get the x by itself. Divide by 50. Divide by 50. 12 divided by 50 gives us 0.24. Remember, that's the decimal. We need the percent. So to get the percent, we move the decimal place 2 to the right. Gives us 24%. That is a nice tip. All right. Example 6. 1,500 people took this survey. How many people chose pecan? So if there were 1,000, we have a pie chart here. We see that pecan has 19% right there, outlined in green at this point. So we basically need to find out 19% of 1,500. The way we're going to do that is we take our 1,500 and we're going to multiply it by whatever that percentage is as a decimal. So we take our 19%, there's the current decimal place, move it 2 to the left, and we have 0.19. Remember, decimals are basically always going to be smaller than the same percentage. So that's how you know whether to move left or right. And 1,500 times 0.9 is 0.19. So 285. For the second part, where we have to choose apple or cherry, notice that for apple we have 21%, and for cherry we have 23%. If we combine those two into one thing, altogether they total out to be 43%. So we basically do the same thing we did with the previous one, but now we have 1,500 times whatever 43% turns into as a decimal, We move it over twice to the left, and we get 0.43. So, 1,500 times 0.43 gives us 645. And these units are both people. So there we have the answers to those two questions. All right. After 6% sales tax was added, a t-shirt costs $9.53. Find the cost of the t-shirt without tax. Okay, so on this problem, we know the shirt is $9.53 after tax, and the tax is 6%. So, 6% turned into a decimal place moves there, we have 0.06. Now we don't want to just put down 0.06 times x, which would be the original cost, because the tax on the shirt was not $9.53. That was the cost after we added tax. Now if you think about it, that 0.06, that 6%, is being added on to the full cost of the shirt. Now what would the full cost of the shirt be? Well, it would be 100% of the cost of the shirt. That's just the shirt's cost. If we turn 100% into a decimal, that gives us 1. So we're going to add that 1 on to our 0.06, and that's the cost of the shirt with the tax. 1.06 times the original amount. So to get x by itself, we divide by 1.06. 9.53 divided by 1.06. We find out that the original cost of the shirt was $8.99. There that is. And lastly, last example. School health records show that 70% of children have been immunized against polio. If the school has 350 children, how many have a polio immunization? So 350 students total. And we know that 70% of them, remember, of means multiplication, have the immunization. So we start with 70%. We need that as a decimal. Move the decimal place over twice. Gives us 0.70. So that's going to be what we multiply our 350 by. So 350 times 0.7 gives us that 245 of the students have been immunized. And there it is. So that is all we have there. Your homework is out of the workbook, and while I do not have it on the slide, it should be either online or posted somewhere in the room. So good luck with that. Do your best, and ask questions if you have any. Thanks for watching.